Eighth grade math. It's Mr. Hussey here. Tuesday's lesson. Tuesday is in the day after Monday. Monday, the day we had off school after Sunday, Easter Sunday. So thankful that Jesus rose from the dead and he's in charge of every rule and authority. He's the highest rule and authority. So hope you guys had a great Easter Sunday, Good Friday, Easter weekend, and God bless you here today. Okay, so we're going to be talking about horizontal and vertical lines. This worksheet. Okay. Now, if you have the worksheet, you can see, you'll know what to fill in. But let's imagine you don't have the worksheet. Then go ahead and pause the video. Make sure you write these down. Okay, and once you have these down, these are two examples. So if you have 1, -5, let's see, how would we plot that? Well, if x was 1, y's got to be down here somewhere. So 1, 2, 3, 4, 5. Let's just make some notches. Doesn't really matter how far apart. So when x is 1, y is -5. When x is 1, y is -2. When x is 1, y is 0. So we know where that one goes. And when x is 1, y is 1, 2, 3, y is 4. So we have these 4 points here, which you can see forms what we call a vertical line. Now, when we have a vertical line, the way you write that is you write down x equals 1. Okay, so for vertical lines, x equals a, where a equals the x-intercept. Okay, so let's break all this down. Let's do the other one first, and I think it's easier to explain. Okay, so on the other one, we have x is -3. And y is -4. So that's going to be like right here. Then when x is 1, y is -4. When x is 2, so I'm getting these off these chart values. When x is 2, y is -4. And when x is 5, y is still -4. So we have this horizontal line. Okay? And when you have a horizontal line, y is going to be equal, in this case, to -4. Okay. And for horizontal lines, so let's write this down at the top. So these are horizontal lines, these are vertical lines. For horizontal lines, y is going to be a, kind of like over here we have x equals a. Y is going to be a, where a equals the y-intercept. Okay, now let's break this down for a minute. Go ahead, pause it, make sure you have all this written down. Then let's think through this. On this one, x is equal to 1 because x is always 1. In every situation. Okay. So x is, think of it like x equals 1 because x is always 1. X is 1 here, x is 1 here, x is 1 here, x is 1 here. And on our graph, right, x is 1 here, it's 1, 4 or something like that, right? Then 1, 0, then 1, -2, then 1, -5. So x is always 1. So we got to think of that line. This line is x equals 1. This line is y equals -4, like we showed down here, because y is always -4. Y is -4 in every circumstance. So let's write down over here, because y is always So y is -4 in every circumstance. So that's how I remember it. So sometimes I see these vertical and horizontal, I get them mixed up, but then I start to think, okay, what would each of these points be? Well, when x is -3, y is going to be down here. When x is 0, y is still here. When x is 4, y is still here. So the y is the one that stays the same. That's why it's y equals. Okay, you may get this mixed up because it looks like an x, right? Left to right. That's how I get mixed up. But the way I get unconfused is I just think, what are the points that will hit this line? So over here, when x is 2, y is -4. When x is 5, y is -4. So y is always the same. So y equals, because it's always the same, -4. Same as over here. Even though it looks like a vertical line, it looks like y equals because it goes up and down. We think of our y values as like this is our y axis, right? Think that x is always the same in this case. So when x is 1, right, y is 0. When x is 1, y is what, 4. When x is 1, y is -2. And when x is 1, y is -5. So x is always the same, okay? So that's why x equals 1, because x is always the same. So that's how I think about those things there, okay? So let's go ahead and take a look at some examples, and hopefully this will make more sense. Okay, so for number 1, okay, take a minute and draw that down if you need to. If you don't have your worksheet, please draw this down. So let's pick a few points. Let's pick a point like here, here, and here. So the top point would be what, -4, 5. And then we would have like -4, 0, right? And then this point would be -4, -5. So in this case, what is always the same? Is the x always the same, or is the y always the same? And since x is always the same, this one's going to be x equals, and in this case, it's always -4. So there's your answer. So this line is x equals -4. All right, remember when we were doing like diagonal lines and we would say y equals 2x plus 1 or something like that? When we have a straight vertical line, then it's going to be x equals, because that's where the x-intercept is, okay? The x-intercept, where it intercepts the x-axis, is x equals -4. That's the x-intercept, okay? Over here, when we see where it intercepts the y-axis, okay? So it intercepts the y-axis right here. But let's also pick some other points, like maybe here, maybe this one. So here we got what, -2, 1, 2, 3, 4, 5, 6. So we go over 2, right, and up 6. On this one, we start at 0, we go up 6. And then this one, we go over what, 2, 4, 5. And then we go up 6. So what stays the same in every situation here? In this situation, it's the 6. And that's not the x number, that's the y number. So in this case, it's going to be y equals 6. Okay, now, the way they also want you to know, based on the notes, is this idea that's kind of confusing, but this part of the notes where it says where a equals the x-intercept, and over here where a equals the y-intercept. Let me try to break that down in a way that makes more sense, okay? Where does this line here for number 3, where does that intercept something? Well, never intercepts the y-axis, right? Never crosses that. But it does intercept the x-axis right here. So x equals 2. So maybe that's a simpler way to think of it. How about this one? This one in number 4 never intercepts the x-axis because it runs parallel, so it's never going to cross or intercept the x-axis. But it does intercept the y-axis, and it intercepts right here, okay? And that would be y equals -1. That's your answer, okay? So if you like this way better, then you can show your work by circling the intercept and telling me what the equation of the line is. So look at this one. It says y equals, even though it's a horizontal line. And this one says x equals, even though it's a vertical line. So you got to think of where does it intercept? Or if this makes, to me, this always made more sense. I just plotted some points and then just thought of it. Okay, which number always stays the same? And that's, like in this case, y is always 6, right? So the line has to be y equals 6 because y is always 6. So this made more sense to me, okay? But this, for some of you guys, you may say, well, this is simpler, so I'm going to do it that way. As long as you can remember it, that's fine. But on a test or something, you got to pull out all stops and make sure you really understand what's going on, like these ones. Okay, so what I would like you guys to do is go ahead and do numbers 5 and 6. Okay. Let's do one of these together, okay? Let's say that, like, number 7, because we haven't done it, like, in the reverse way. When they give you the equation, now we have to draw the line. So if y equals -7, then y is always -7. 1, 2, 3, 4, 5, 6. So when x is 0, y is -7. When x is 2, y is -7. When x is 4, y is -7. Hopefully you get the idea here. Y is always -7. Y is always -7. So this line would look like this. Because in every situation, y is -7. All right, now when you have an x equals something, obviously your line will go up and down. It'll be vertical, okay? All right, so you're going to do 8, 9, and 10. And then down here, let's see what's going on. What's the slope of the line y equals 5? Okay, what they're looking for here is if, let's just draw a little, if y is always 5, okay, so when x is 0, y is 5. When x is 1, y is 5. When x is 3, y is 5. So if y is always 5, then the line's going this way, okay? And what do we remember about horizontal lines? Okay, horizontal line, the slope is 0 over something, like say 0 over 5, so it's a slope of 0, okay? Whereas vertical lines, when we get a situation like this, when x is -2 here, and x is -2 here, and x is -2, y is 7, and x is -2, y is -7. So when x is always -2, our line looks like this. And because it's a vertical line, then that's what we call an undefined slope. So our slope is undefined. So for these here, you're always going to get an answer as 0 or undefined. For undefined, it's a vertical line. For 0, it's a horizontal line. So go ahead and do number 13 and 14. And then go ahead and try 15. Okay, 15 is like the first part's what we've been doing today. And the second part, y equals 3x. Let's just think about that. That's actually in the form mx plus b. So in this case, since there's nothing after the 3x there, it's going to cross at the 0 because it's not like 3x plus 1. It's not 3x minus 1. So it's going to cross at the origin. And then the 3 is your rise over your run, okay, or your slope. So in this case, to get a slope of 3, you need to be like 3 over 1 or 6 over 2 or 9 over 3. I like to do 3 over 1. So every time we run 1, we rise 3. We run 1, we rise 3. And then reverse order. So 3x is going to look something like this, okay? Where y equals 3 is going to be one of the ones we did from today, okay? And then if you can, please go ahead and just explain the difference there. So y equals 3 will look like either something like this or this one, okay? So that's it for the lesson today. Please do the problems we did together and then do the remaining problems on your own. The teaching part here took 15 minutes. Hopefully your work will only take about 15-20 minutes today, and you'll be less than the class period. So God bless you guys. Hope all is well, and have a wonderful day.